Hello everyone. For our chatbot, we are using Rasa NLU framework. Rasa NLU is an open source natural language processing tool for intent classification, response retrieval, and entity extraction in chatbots. Rasa NLU has a special kind of data format. This is basically our dataset. We have prepared our dataset as questions that people usually ask to bank employees at customer care centers or inquiry desks, and categorize the questions according to their intents. Training data can be provided down as markdown or as JSON. So here we are particularly using the JSON format. As you can see, data.json. The training data is structured into 4 different parts, but basically we have used 3 over here. So as you can see, this is Rasa NLU data. uh, it has got regress features, entity synonyms, and common examples. So these are the 3 parts of our dataset. So we will discuss this in details. So as you can see in common examples, uh, so these are the examples. They are closed by parenthesis. Now they has got 2 parts, texts and intents. Now there's various other types of examples. Now other than texts and intents, we also have entities. For example, in this entity, we have the text help me for my card pin. So the start is 21 and the end is 24, and the value is pin. So its entity is using what. So in this way we can format the dataset into its entities. So this is how common examples are created. We can say another example here. Please assist me to turning on card pin. So the intent is banking activate card. Entity is 36 and 39. So from index 36 to 39 we have got pin. So it's also have the entity using what. So next we have the entity synonyms. Now entity synonyms are nothing but we are grouping a group of words which have similar meanings and giving them a value. For example, as we can see in the first example, uh, we have apple, application, call, demand, desire. All these indicate the same meaning, which is request. So we have so next we have the regex features. This is nothing but we have uh, defined various regex according to the pattern of words and symbols that we are using. For example, in zip code it uh, starts with 0 to 9, any digit, and it ends with 5. Similarly, for banking email, this is the regex features. So this is our basic project folder, and in here we have the data set that I explained right now is over here. And as you can see, we have used the Rasa NLU framework, and in here we have got all the files and everything, all the codes that is being used in the framework. And here are the modules that we are going to use. We will discuss everything in details. Before that, first we need to understand how the Rasa NLU pipeline is actually working. So this is the Rasa NLU pipeline. So first we need to understand what exactly is a pipeline and how it works and why it is being used in Rasa NLU. So the pipeline has got various contents, and one content works after the other. So as we can see in this example, here are various components. We have only 3 components over here, component A, component B, and this is another component. So context is nothing but the input means the raw training data that we have. So we have to give the training data in the first component, and in the end that the output that we get, that is model metadata, that is obtained at the end of the last component. So first when we give the input, the first component is created, and then we have the pipeline initialization of component A, and after that we have the create of component B. So what exactly happens over here? Now after the component A is created, it transfers some data which is being used by component B. Component B is going to use some parameters and some changes which are being done by component A. So that's why uh, the context of component B is nothing but the output and the initialization of component A. In the similar way, after the pipeline initialization of component B, it is going to the last component in the create format. So after the whole pipeline is created and the pipeline initialization is done, it starts the train. All the components are trained one by one according to all the datas, and finally we have the persist. So what happens in persist is that the model that is being trained and all the parameters of the models are stored in a file. Now if we see, so we are persisting the model, as you can see in here. So whenever the persisting is done, the model metadata are stored in this folder. So we now need to understand how the pipeline is actually functioning. So these are the files which are controlling the pipelines, and in these folders we have different components. We'll discuss the components in details later, but first we need to understand the codes for the pipelines. So we will open registry.py at first. Now when we look into the registry, there are some mandatory libraries which have already imported. Now next we can see that here we have imported all the components. Now I can give you an example. For example, Rasa NLU.classifiers.sklearn intent classifier. So what does this mean? uh, Now classifier is a component. Inside classifiers we have the sklearn intent classifier, and inside sklearn intent classifier.py file we have this class sklearn intent classifier. So this is what we are importing here. Similarly, we are also importing all the other components which will be required in our project, and these components are actually forming the whole pipeline. So next we can see there are the component classes. We have grouped them into a list called component classes. Next we have the registered components. So this is nothing but a dictionary where the key value is the name of the component, and we have the component object as well. Registered pipeline template. So this is the pipeline that we are using, Spacey sklearn pipeline. So here the first is the NLP Spacey component, then we have a tokenizer which is Spacey tokenizer, then we have the intent featurizer Spacey, and then we have Regex featurizer, then we have two extractors, nercrf and ner synonyms, then we have the intent classifier sklearn which is working as the main classifier. So next we need to understand these three functions. Now what does get component class does? It basically resolves component name to the registered component class. So what does that mean? For example, we have imported all the components, so we pass the component name over here, and what we obtain is the component object that we have imported. Load component by name, it calls the load method of each component. Create component by name, it does the same thing, it creates the component, calls the create method of the component. So next we need to understand this file components.py. So what do we have here? We've imported all the libraries. Now this function is required in the training phase, validate requirements. So what does it do? We pass the component name into this function. So if there are any unavailable packages, whatever are the dependencies of a particular component, then it raises an exception that those required packages are not present, and if all the dependencies are satisfied, then it doesn't do anything. This is the component class. Like I said before, we have used these many components which are included in our pipelines. So every component has got a class, and this is the abstract class for the component, which is later being implemented by all the other components. So this is nothing but like a blueprint or the outer framework of every component that we are using. These are the methods of the component, like we have used before. We have got the load and we have got the create, which we had used in the registry, like I said before. Here these methods were called. Next we have the train. Here inside the train we don't actually have anything, because this method is actually being implemented later. by various other components. So we have got two methods over here: prepare partial processing and partially process. So what exactly happens over here? For example, if we consider component B, whatever processing is taking place before it, that is nothing but prepare partial processing. And for component B, we have partial process, because it is going to process only after all the parameters and components before component B is actually pre-processed. So for that, partially processing means this component B is going to process, including all the datas which have been pre-processed in the components before component. Next, we need to understand the component builder class. Now, in self.component cache, it is basically a dictionary which is storing all the cache values of each components. This cache concept is used so that each component is can be reused. So this helps to save memory. Get cached component, what it does nothing but it loads a component from the cache if it exists. It returns the component if found, and also returns its cache key. Add to cache, what it does, if the component is not present in the cache, that is self.component cache, then it adds the component to the cache. So basically we are storing all these components into this component cache dictionary. And load component does nothing other than it calls the load method of each component from the cache, and if it is not present in the cache, it adds the component to the cache. Create components does the same thing as load component, just that it calls the create method of each component, and similarly it calls it from the cache, and if it's not present in the cache, it calls it from registry and then adds it to the cache. So next we are going to discuss this file model.py. So here all the basic functionalities are taking place in here. So here we need to first understand this class trainer. So before anything is trained, this an object of this trainer class is created, and that's how the training takes place. So what happens when this object is created? So we need to see the init of this trainer class. So what happens, we have the config parameter component builder. So in configuration, we are actually pass the configuration of the whole project. So all the configuration informations are here, and in skip validation, if it's false, then we are going to check all the dependencies of each component, and if it's true, then we don't need to do that. So next, in self.pipeline, we have declared a list. In this we are going to store all the components sequentially in the way that pipeline is going to flow. Next we are creating the component builder object, the component builder that we discussed before. Next we have, so if the skip validation is false, then we are going to validate each component. So what it's doing, validate requirements, it's going to check all the dependencies, and if the dependencies are satisfied, then it is going to pass successfully. In other case, there are going to be raised exceptions. So see, we can see here that in configuration of pipeline, whatever is being passed, we are creating a component of each name in the pipeline, and it is being saved in self.pipeline. Next we are going to understand the train method. So in this train method, we are passing the training data. So we are saving that into self.training data, and here we have the context dictionary. So we are going through all the components in the pipeline that I discussed before. We have stored all the components according to the pipeline, that is the objects of each component, and in the updates we are saving the context of each component. If it has got any context, then it will provide it, but usually in our project we don't have much provide context. Now we are validating each component once again. In the working data, we are creating a copy of the data for by chance if the data is lost, then it will be saved in this variable. Now we are enumerating through each of the component in the pipeline. Now the prepare partial processing is taking place like we discussed before. Now we are going to train it. Component.train working data, and we are passing self.config. So the train method of each component is called. After it is trained, it will also update the context if there are any updates. And after that, since this is a loop, it will go to the next component, and similarly it will prepare the partial processing data for the second component, and so on. It will train that component, and so on it will continue, since till all the components in the pipeline is trained properly. So this is how the workflow that I discussed before, the training phase is done. So next we have the persister method. So what is happening over here? The main functionality of the persist function is basically to save all the components in the pipeline to the path that we have defined over here. So we have created a metadata dictionary over here. In this dictionary there are two keys, language and pipeline. So in language we are just saving the language from the configuration file, and in the pipeline we are saving the actual paths, like the actual paths of the classes of each component, and we are saving it here. Next we are setting the project name. We are setting the model name from the fixed model name, else the model name is set by default. Next we are creating a directory, as the directory name has been passed from the path. So we are going through each of the components in the pipeline, and we are updating them in the metadata. The metadata we discussed before over here. So the persist method of each component is called, and it is saved in the update, and this update we are storing in the metadata. Similarly, finally we are calling the metadata object, and we are calling the persist method of that. In this way, after each trading process, after the model is trained, all the components are persisted and they are saved in model metadata. So this is our main running interface, this file. Okay, so we have got everything in this. We have imported the Rasa NLU pipeline over here. So since we have already understood the pipeline, we need to find out what is actually happening. So first we have installed all the requirements. This I have reinstalled because it takes some time. In requirements.txt we have mentioned all the libraries which are actually dependent to run this one. Next we have downloaded the Spacey English version. Next we have imported the required functionalities which are required. Now the trainer is the same trainer which we discussed previously, the trainer class that was defined in model.py, one that we previously discussed in this trainer class. This is the same trainer class, so that we will be using. So next we have defined the train NLU function. Here we have provided the data as attribute and the configuration and model directory. Since we are talking about configuration, we will see what is there in the configuration file. So this is the configuration file. Here we have defined the name of the pipeline. Here we are using Spacey sklearn. We have defined the path of the model where we are going to save the model, that means the persisted data, and we have also the path to the data, that is data.json. So in this train function we have first loaded the training data, that is equal to load data of data, and then we have defined the trainer. We have declared the instance of the trainer class, that is trainer equal to trainer of Rasa NLU configuration of configuration. So this trainer object is created, and when we call the train function of the trainer object, this train method will be called, which we discussed previously, and all the functionalities, the components will be gradually trained. So let's see what happens. So let's first import all the libraries. We are running this one. Then we define the train method, and finally we are also persisting everything in the model directory, uh, that is in here. In the models we are going to save it. Then we start training the model. So the training will certainly take some time. So we have discussed the working of the pipeline before, and we have understood how each of these components are being called and trained sequentially. So today we are going to discuss the pipeline that we have used. This is basically the Spacey pipeline, and there are total 7 components. So first we have the Spacey utils, then we have Spacey tokenizer, we have two featurizers, Spacey featurizers and Regex featurizer, two entity extractors, one is CRF and entity synonyms, and finally we have the sklearn intent classifier. This intent classifier contains machine learning algorithm which is actually working for the classification. So first they are created and initialized, then they are sequentially trained, and finally persisted. So we will discuss each of these components in details and how they are working. So as you can see, we have got all the components over here in their folders. So we have actually broken down each of these codes, and we are going to show you how they are working by running and show the output of each of them. So first we will find out what is taking place in Spacey utils, this file. So we will understand the code and find out. Okay, so first we have a little of the pre-processing. We are importing the load data from Rasa NLU. Then we are loading the data. Since we have it here, then we are importing from Rasa NLU.configuration file, Rasa NLU method. Then we are fetching the configuration into config. Next, what is taking place in utils.py? First, we are importing the Spacey library. Spacey is nothing but a library which adds some special features to the text format. So we have to download the English version. Now, what exactly is this Spacey is that you can find out in these websites. There are some features, for example, tokenization parts of speech, which is added to the raw text. So that's why we are downloading the English version. This may take a while. Okay, so this is done. So from the configuration, we need to find out what language actually we are going to use. So this must be nothing but yeah, as you can see, it's English. So we need to next create the NLP object, which can be done from the Spacey library, Spacey object. We're calling the load method, and the NLP object is created. Now this NLP object we will be using to create a Spacey feature for each training examples. So for each training example that we have in our dataset, we will be creating a feature called Spacey doc. So when we run this loop, what actually is happening? So you can see in this diagram, there is the training data, and in training examples we have already. And for all the examples, if we choose one example, for example, this is change my password. So we are creating a new feature, Spacey doc, and for that feature uh, we are adding new attributes to each data. For example, change my password. So for each tokens, it has got these many features which is provided by Spacey utils: text, lemma, parts of speech, tag, depth, shape, alpha, and stop. So we will use these features to which will be helping in training the model. So you can find it in this description. So this is exactly what is going on in Spacey utils. As you can see, if we look into a data, this is the training data. So it shows please help me to re-enable ATM card passcode. Now if we find out the Spacey data for this one, for the Spacey feature, for example like this one, so we will get this one only. So the first index, which is help, and if we find the parts of speech for this one, it's showing verb. Instead of parts of speech, if we give something else like shape, what is going to happen in that case? It will show the shape. So that's how this is working. So this is what is happening in utils. So next we will find out what is happening in Spacey tokenizer. So we have the file over here. Inside tokenizers, we have Spacey tokenizer to buy. So we'll find out what is happening over here. So in Rasa NLU tokenizer, we are first importing it. We're defining these methods. So what is actually happening? First we are displaying one training example. So it's the same, please help me to enable ATM card passcode. We are saving it into message variable, and then we can find out that the text has been split into tokens. So according to this, if we show the index 1, then it's showing help. If we go to 0, then it will show please. And other than text feature, we can also find out other things like offsets. So its offset is help is starting from 7th index, that's why it is 7. Basically from training, it is going through all the examples, and for each example it is creating tokens, dividing them into tokens and adding the features, text, offset and end. Change my password, that is all this is doing. So next we will find out what is happening in Spacey featurizer. So we have the Spacey featurizer inside featurizers. So we'll find out what is happening in this file. So as we can see, if we look into the first example, 350th example, we have the same thing. We are storing it into message variable. Now if we find out the text features of this message, then we will find out that it's empty. Now after featurization, what will happen? These are some dependent functions combined with existing text features. So this has been run. So through all the examples we are iterating, and we are setting Spacey features for that. So after featurizing, what is happening? We are storing it in message variable. Then if we see the text features, and we can find out there are so many values, and this is nothing other than a vector. So for one message we have this vector. So for, if we see the length of this, it's 300. So this is a 300 dimensional vector. So how is it doing this? This is the Spacey featurizer. It is iterating through all the training examples, and for each example we are setting a 300 dimensional vector. This is acting as a feature which will be helping in the training process. These are all the variables, training data. It's actually finding out the vector using the same Spacey doc file. The Spacey doc file, that's what stored the word vectors, and we are setting the word vectors for each text messages. Let's see what is happening in Regex featurizer. So as you can see, What this is doing, it is iterating through all the training examples, and for each training examples we are adding a feature text features. Initially we have seen that in Spacey featurizer we have added 300 dimensional vectors, which you can find here. Now in Regex featurizers, it is going through all the tokens of each example. For example, in this example, my email is deparna@gmail.com. So it is searching and matching through all the rejects, like email rejects, it must have a pattern, date rejects, passcode rejects. So it is seeing if it is matching with any of the tokens. If it is matches, then it shows 1, since this one is matching, and or else it is 0. So these research features are added to the text features. So instead of 300 dimensional, it will the dimension will increase to some extent depending on the number of reject features we have. So we have the reject features, the text features are updated, and this will help a lot in the training process. So how are we doing this? Inside featurizers we have the regex featurizers. So let's see what is happening over here. So regex featurizers, first we are going to find out what are the known patterns. So we are finding the regex features which was given in the dataset. We have discussed before that in the dataset we had the regex features. So let's see what are the known patterns we have. So you can see zip code, general greeting, we have so many rejects. So let's featurize it. These are some dependent functions for regex featurizing. So here we are going through all the training examples and text features with regex. So this is what we are doing. We are updating, extracting the regexes using these functions. So let's see an example. Let's find the first intent example. So it is nothing but my mail ID. So we are saving that into a message. Okay, next let's print the text features of this message. So as you can see, these are all the vectors, and if we find the length, it's 301. So as you can see, this is just because this is a mail ID, so an extra regex feature has been added to it. And since this is just a mail ID, so only one feature has been added. Next we will see the extractor. So let's see what is taking place in CRF entity extractor. So actually in the same way we are iterating through all the entity examples, picking them up, and we are picking up the entities if that example has got any. For example, in this one, from 4th index to 7th index we have the name entity, which is Dev. Then we are creating a data set which includes all the examples. For each example, we are converting the entities from JSON format to CRF format. Now CRF has got various types of features. Now that if the entity that we are picking that matches with the CRF entity, then we are labeling that with the entity name. For example, Dev has got uname, but if it does not have the other token does not have any entity which matches with the CRF entity, then we are marking them as O. So this is how it is working. So let's find out what is taking place in the code. So first we have the training configuration. We are getting that from configuration.getNER CRF features. So these are the CRF features. This is just some reprocessing, taking the maximum iteration. L1C, L2C. We have the function dictionary. Here some different features are described, and here are some method definitions which will work and help in featurizing. extracting the features. So let's find out how the dataset is actually created. So we will take an example. Let's take this example. Hi Aviral, how is it going? So certainly it has got an entity which is name, which is Aviral. So we are going to convert it, convert examples. We had this function over here. So what it is doing, so as you can see, it has obtained the name which is Aviral from 4th index to 10th index, and that is name. Now we are converting these examples as entity offset, and from if we do from JSON to CRF, we can see the whole we have obtained the tokens of the whole sentence, and each one has been marked according to the CRF entity. For example, we have the uname CRF entity, so it has been marked. Others has been marked O because they don't have, they are not any entity. So the main function of CRF entity extraction is to tag, to create tags of each token which has got an entity. Next, we are saving them as a data set. So we are creating the data set of this. Like I said before, over here, we're creating the data set. And now this data set is ready to be trained. We're clearing the output. Now let's see what has happened in the data set. Let's find the 9th example. Yeah. So you can see it has been, tags had been added to each token. Now we will train the dataset. This is a function which will convert the sentence to features, and this is a function which will convert sentence to labels. Uh, so let's see, we will use the sklearn CRF suite to train the dataset. So first we will obtain the xtrain, that is from dataset we are picking up all the elements and converting them to features, from sentence to features. So let's take this example, the same example. So what is xtrain of this? So you can see it has converted the sentence to features. So this has got many features, CRF features. So these features has been converted to CRF features. Now in the y train we are getting this. So this is the label for it because we have the same entity over here, the uname. Now we are describing the model which is sklearn CRF suite, and we are using the CRF trainer for this. Here are some specifications for that. Now we are going to train it. So the training is gonna take a while. After this is trained, uh, we will have the dataset trained as below. So this is how this is going to work. So next is entity synonyms. Let's find out what is actually happening in entity synonyms. So actually uh, it actually comprises of two steps. One is this one and the other is this one. So actually we are, from the training data, we are extracting the entity synonyms that actually we had discussed before in the data set, like this. Yeah, entity synonyms, like there are various values, and according to them we have segregated various synonyms. For example, account, we have all these synonyms. For request, we have these synonyms. So that is exactly what is present in this entity synonyms. So for request we have these many meanings, for transaction we have these many meanings. So here what is actually happening, that we are creating a dictionary called synonyms, and we are uh, finding out all the synonyms and we are keeping them as keys, and the value of all those synonyms are put into the values. Like you can see, we are actually taking out everything from here and putting it in a dictionary, in a single dictionary. So let's see how this is happening in the code. So here we have the synonym dictionary. Currently this is just blank. So let's run it. And here we have defined a function add entities to synonyms. So this is just going to add the keys and values that we will be providing and add it to the synonyms dictionary. So let's see. So we are first going to list down all the training data entity synonyms that is present already in the training data. So as we can see, this is the one. So I am going to take out all the entity synonyms and add it to the synonyms. So now you can see, if we find it, all the values are added to the synonym dictionary and they have got the value, as you can see. Now if we see the length of the synonyms, then it is going to be 145. That means we have put down all the values. Next, the second step that we are going to do is we are going to take out all the entity examples and find out the entity values. For example, email, it is this email ID, the account number, this is it. So we are going to take out all the entity examples. We are going to give the values of the entities as keys in this dictionary and uh, the entities as the values. So we are also going to put them over here. So let's code that down. So this is what we are doing in this loop. That's it. So now when we see the length of the synonyms, it is 163. Previously it was 145, which proves that the extra entities synonyms has been added. So that's how the entity synonyms file is working. So we have this final component which is called sklearn intent classifier. This is the main part why we have been doing all this pre-processing. So this contains the machine learning algorithm which is going to do the classification. So we are going to find out what is happening in here. So like we see that we are importing the label encoder, then we import numpy. So now we are creating a list called labels, and we are taking the intent examples, that is we are getting the intents into it. Now this function is going to transform these labels and going to encode them into numerical values, which is actually helpful for machine learning algorithms. So we are going to store it inside y after transforming. So as you can see, the labels are showing the labels that we had found in the dataset, that is the intents. In the common example, the intents are nothing but the labels. So we have got the labels over here. Next, as we can see, inside y we have transformed those label and stored it as array, and they have been given some numerical values. Now we are going to train the independent variables, which is nothing but text features. The text features which we had done previously in Spacey featurizer and Regex featurizers. So those we are going to use as independent variables. So this is what we are going to do. So training data, as we can see, the 350th example that we have is this one we had been using, and we have the value as the featurized values, that is the word vectors that we have used before. So these are going to be the independent values as the training data. Now the model that we are using is SVM, support vector machine, and we are importing the SVC. This is going to perform the classification. So here we have given the C value as 1. By default, probability is true. Class weight is balanced. From sklearn.model selection, import grid search CV. Now grid search CV is nothing but it is able to find the best hyperparameters which is good to provide the best accuracy. So here are some of the dependent values for grid search CV. So we are going to put the classifier inside the grid search CV, and grid search CV is going to find the best hyperparameter which is best which provides the best accuracy. So these are all the attributes that we are giving. So yeah, we are defining the final classifier as CLF, and finally we are going to train the whole model, which is clf.fit x comma y. So this has started the training process, and this is gonna take a while. So this is how the SVM actually is working. Basically, SVM uses a hyperplane, as you can see, to classify uh, different kinds of data and categorize them. So hyperplane is nothing but a decision plane which separates a set of objects having different class membership. So how does the SVM actually works? It generates hyperplanes using various ways. Like it can generate it by segregating the classes in the best way by left hand side figure, or it can uh, select the right hyperplane with the maximum segregation from either nearest data points. So since we have discussed this before, uh, like everything that is happening till now, everything that we have discussed in the whole training process, from pre-processing, all the cores that we have discussed of each component, everything that is present in all these components. So like I said, everything is actually happening in here in this train process. So this is our main file which is controlling everything. So like we discussed before, I have installed the requirements and downloaded Spacey, and these are the important functions of the Rasa NLU. Now we have here defined the training process, like uploaded the training data and defined the trainer object. And when we do trainer.train, so it passes through all these phases. First creates and initializes all the components, and then it starts training them. So this is what happens over here. So after we define this function, and also all the components are persisted into the given directory. So this is our directory where we are saving it, this one. Inside models, we are persisting all the components to be further used for persistence. So we have defined this function. So executing this, the training process has started. So this is gonna take a while, and till it gets persisted, we will find all the files over here. Model training has completed, and now it is time for testing. So after the model has been trained, you can see uh, all the persisted data are present inside this directory. So we are going to use these data to predict the intents of our own utterances. So first we are going to define this function run NLU. So what is happening, we are giving a string as a parameter, and it is loading the interpreter, creating an interpreter object using these models. We have given the path, and it is using the configuration file. So when it is calling the interpreter.parse, it is calling the parse method. You can see uh, this is the parse method which is being called, which is present in model.py file. And so here what is happening, we can see a message object is created, and through each component this message is processed. The process method is called, and finally in the output we are getting the output that is obtained from the final model. So this is how the intent is actually predicted. So let's run this. So we have given an input, please assist me to prepare me my a card resource status. Okay, we are going to delete this in my card resource status. So first we are going to define the function, then we are going to run it, and as you can see this is showing the intent bank get card status request status. So its confidence is 89%, so this is definitely the right intent. Let's find something else. I want to activate my card. So let's see what it shows. It's showing the intent as bank activate card, and its confidence is 0.99, which means 99%. So this is quite a good accuracy that we are seeing. We can also modify it. Can you help me activate my card? Let's see if it's able to understand an interrogative question or not. Yeah, definitely. And also the confidence is 98%, which proves that our model has been trained very well and it is able to predict. Um, so we need to see if any other types of utterances are going to show proper predictions or not. So this is how it is working. Thank you very much.